Okay, number 65 is a pretty tough problem to kind of wrap your head around. We talked about independent events today, and that's what this problem starts out with, independent events. Remember, independent means the outcome of the first has no effect on the outcome of the second. Okay, the example that is in the book and the example I used in class is what's if probability of A is rolling a 6 and probability B is rolling a Really? All right, now that the fart alarm is done, number 65, where were we? Okay, probability of A, probability of B. Independent events mean this happening has no effect on this happening. That'd be like the probability of rolling a 6, probability of rolling a 3. So part A says, what's the probability that they both function? Meaning that the probability of A happens, and, remember, and in probability typically means multiplying. So probability of A and B both functioning, we're going to multiply them. That would be 0.985 times 0.985. 0.985 squared is about 0.9702. Okay, so part B, we're going to come back to part B. We'll do part C first, because part C is a lot like part A. Part C says, well, what's the probability that they both fail? So the probability that the first one works is 0.985. But what's the probability that part A doesn't work? That would be denoted as a, you put a little slash here. Well, it's going to be the opposite of the probability of A working. So 1 minus 0.985, or 0.15. Okay? And obviously the math for the second one is going to be the same. 1 minus 0.015. 1 minus 0.985. 0.015. Okay, so the probability that they both fail would be 0.015 squared. 0.015 squared. On my calculator it says 2 times 10. You know what, I'll put the whole thing down. 2.25 times 10 to the negative fourth, or 0.0002 rounded off. All right, so back to part B. Part B says, what's the probability that you have at least one system that functions? Okay, well, let's just kind of walk this out. What are all the possible scenarios? Well, the first one could work. The second one could work. The first one could work. The second one could fail. The first one could fail. The second one could work. Lastly, they both could fail. So these are all the different scenarios. Now, which of these satisfy part B, which says at least one system functions? Well, here, one of the systems functions. In fact, they both do, but at least one does. Here, one of the system functions. And here, one of the systems functions. The only one that doesn't work is this guy way over here. Okay? So to figure out part B here, we could find the probability that this happens, or we could find the probability that this happens and take 1 minus. All right. So either, where was I? So either we add up all these probabilities, or we just need to take 1 minus this probability, and here's why. Let's say this is just probability that C happens. Probability that C happens is at least 1 functions. At least 1 functions. What's the opposite of that? Well, I've circled at least 1 functions. The opposite of that would be this guy right over here. So sometimes in probability, to find what you're looking for is difficult. To find the opposite of that is really easy. In fact, we just did this in part C. We just found the probability that they both fail. So part B, we can do 1 minus fail, fail, which would be 1 minus 0.000225, right? This number right here, which is about 0.999775, or 0.9998 is what the book says. The other way to do it would be to do that, which is 0.985 squared, plus that, 0.985.015, multiply that, plus that, 0.015.985. So if I take this, plus this, plus this, I'm also going to get 0.9998. This is a test question.